Hello everyone, welcome to Chemistry Concepts, and this time I am continuing the second part of environmental chemistry. In the last class we have discussed about introduction of environmental chemistry, Earth's atmosphere, and then depletion of ozone layer, and what are the reasons or consequences for the depletion of ozone layer. Mainly the four reasons are nitric oxide, greenhouse gases or global warming, chlorofluorocarbons, that is CFC, and then acid rains. So in this video I am explaining you about those four consequences which I did in the last video. So one of the reasons is nitric oxide. So nitric oxide, it catalyzes the decomposition of ozone and is regenerated again to repeat the cycle, and this cycle is believed to destroy about 70% of ozone formed in the stratosphere. A larger concentration of nitrogen oxide in the atmosphere leads to a greater depletion of ozone. So that is, nitrogen monoxide on reaction with ozone, it forms nitrogen dioxide plus oxygen, and nitrogen dioxide plus nascent oxygen gives rise to nitrogen monoxide and then oxygen. And at these high temperatures, nitrogen in the atmosphere is oxidized to oxides of nitrogen, that is nitrogen plus oxygen, it gives rise to nitrogen monoxide, and then that nitrogen monoxide reacts with oxygen to form nitrogen dioxide. And thus the concentration of NO in the stratosphere is thus increased, which in turn results in a larger depletion of ozone layer. And then next one, that is chlorofluorocarbons. In the short form we call it as CFC. And these chlorofluorocarbons are useful as coolants in refrigerators. Normally in a way of home we can see refrigerators. So in the refrigerators we can see this chlorofluorocarbons equipped as coolants. They are using as a coolants in refrigerators, and in air conditioner also they are used as a coolants as aerosol propellants. Refrigerators we are using it as a coolants, and in air conditioner we are using it as a aerosol propellants, and also as a cleaning solvent for electronic circuit boards, because they can be easily liquefied and they are non-toxic and non-combustible. And when these compounds are eventually discharged into atmosphere, they do not react with any substance but just upfloat through the atmosphere and finally enter into the stratosphere and decomposed by UV radiation, forming chlorine-free radicals. The chlorine-free radicals catalyze the decomposition of O3 similar to NO, that is nitrogen monoxide. In this you can see the chlorofluorocarbon CFCl3 gives rise to CFCl2 plus chlorine-free radical, and chlorine-free radical, it reacts with ozone to form ClO plus O2, and in turn it gives you chlorine-free radical plus O3, that is ozone. And then the next one, greenhouse effect, a very familiar word, or the other word for this greenhouse gases, or otherwise we call it as global warming, which is a very widely used word in today's world. So what is global warming? The influence of certain gases on Earth's atmosphere is called greenhouse effect or greenhouse gases. Normally, what are those gases? Those gases are nothing but carbon dioxide, water, methane, CFCs, that is chlorofluorocarbons, nitrous oxides and various other volatile organic compounds are called greenhouse gases. And the sunlight warms the Earth's surface. When the Earth radiates this heat back into space, the greenhouse gases absorb it, re-emit a part of it back to Earth's surface. This results in the increase of average temperature of the Earth, and this is called a global warming. So why how can you simplify this? Is nowadays the temperature is increasing day by day. The reason is the gases which are releasing from the industries or factories or whatever, the chemical industries. These gases, these harmful gases like carbon monoxide, sulfur dioxide, methane, or any other volatile organic compounds, what they do is when the Earth radiates or when the sunlight warms the Earth's surface, the heat back into the space. That means after the sunlight warms our surface and the Earth radiates the heat back into space, and this heat of the sunlight which radiates back into space and the greenhouse gases absorb it. That means gases which are present around the atmosphere, it absorbs those heat and re-emit of it back to the Earth's surface. Just in order to say, if you want to simplify it, you can say that the heat of the sunlight, when it falls on the Earth's surface and when it returns to the atmosphere, and in the atmosphere when the greenhouse gases are present, it absorbs a part of the heat and sends the remaining part of the heat to the Earth's surface. That is the reason why the temperature of the Earth is increasing, and this simply we call it as global warming or greenhouse effect. And then next one, that is acid rain. What is acid rain? Acid rain is a term referring to a rain having a pH less than that of the natural rain. The pH of the normal rain water is about 5.6 because the acidity is due to the dissolved gases of carbon dioxide, sulfur dioxide and nitrogen dioxide. And these three, that is carbon dioxide, sulfur dioxide and nitrogen dioxide, which are the harmful gases or which are the reasons for the depletion of ozone layer, comes under this, these are the sources for acid rain. And we have some other sources like combustion of coal and petroleum products, metallurgical process, volcanic eruptions, and burning of other fossil fuels like oil also produce SO2. You can see here FeS2 plus oxygen. It forms ferric oxide, and that is liberation of SO2. And the SO2 present in readily converts into SO3 in the presence of ozone, and both SO2 and SO3 dissolved in rainwater to form respective acid. That is, here we have given this SO2 plus O3, that is sulfur dioxide, reacts with ozone to form SO3 plus oxygen. Similarly, oxides of nitrogen also converted into nitric acid. NO plus O3 gives rise to NO2 plus O2, and NO2 plus O3 gives rise to NO3 plus O3, and NO3 plus NO2 gives rise to N2O5, and N2O5 in reaction with water it forms nitric oxide. That is, oxides of nitrogen, it converts into nitric acids. Oxides are converted into acids. And what are the effects of these acid rains? The acid rains increases acidity of the lakes and damages the aquatic life. That means fishes or any crabs or any sea animals, and causes dissolution metals like aluminium, mercury into natural waters. That means which are toxic to fish and human. And what are the remedial measure of acid rains? How we can control acid rains? how we can control, the first thing is how we can control sulfur dioxide. You can control it by mixing with limestone. Release of this sulfur dioxide by the combination of coal is controlled by mixing with the limestone. So mainly what we are discussing, SO2, CO2 and NO2. These are the gases which are harmful, or which are the sources for acid rains. So CaCO3, that means calcium carbonate, it gives rise to CaO plus CO2, and when this calcium oxide reacts with sulfur dioxide, it forms CaSO3, and 2 moles of calcium oxide and sulfur dioxide and oxygen reacts to form calcium sulfate, and this CaSO3 and CaSO4, they can be easily removed, and the SO2 released from metallurgical process can be converted to SO3 and then to sulfuric acid. And next one, that is photochemical smog. What is a photochemical smog? The word itself gives you smog. Smog is nothing but smoke plus fog, that is equals to, which is nothing but smog. Smoke plus fog is equals to smog, which is defined by the interaction of sunlight and automobile exhaust. And the substance involved are oxides of nitrogen, ozone, carbon dioxide and various unburned hydrocarbons. These are called primary pollutants, which themselves are not very harmful. Secondary pollutants are formed photochemically from primary pollutants and are responsible for the formation of the smog. How smog is formed is NO2, that is nitrogen dioxide, reaction with the sunlight, it forms nitrogen monoxide plus nascent oxygen, that is primary pollutants, the substance involved with the interaction of sunlight. And then the NO2 released from automobile engines absorbs UV radiation from sunlight, undergoes photolysis to produce atomic oxygen. And atomic oxygen is a highly reactive species that can bring out a number of reactions. Here, nascent oxygen plus oxygen, it gives rise to ozone, and O plus RCH3, it gives rise to RHCrCH2, that is a free radical. This free radical on reaction with oxygen, it forms RCH2O2, and which on nitrogen monoxide forms RCH2O free radical with the liberation of NO2. That means the reaction, here NO2 is formed in this manner by the reaction with the free radical. And then effects of smog. What happens when the smoke plus fog is mixed, that is when a smog is formed? Majorly you can see eye irritations, breathing problems, severe lung and throat irritations, and poor visibility also. What are the remedial measures? How you can control this smog? A few measurements, that is automobiles must be provided with oxygen and reducting catalyst system, and the oxidation catalyst must oxidize a complete hydrocarbon to carbon dioxide and water. The reducing catalyst must reduce oxides of nitrogen to nitrogen and oxygen. And then water pollution, the word which are familiar from a long time. How water gets polluted is there are many sources of water pollution, that is from industry wastages or chemical industries, or by air pollution, oil refineries, tankers, offshore rings which contribute to residues, and the seashores gets polluted normally by man-made mistakes, and crude oil, the leakages of crude oil, which you can see, which you are familiar with the recent incidents, and the fertilizers and pesticides what we use in today's life. These are also sources for water pollution. And how you can treat water, treatment of sewage water. So the wastewater allowed from houses and institutions and industries is called sewage water. Normally there are three types of treatment, that is primary treatment, secondary treatment and tertiary treatment. And the primary treatment, sewage water containing suspended particles of all kinds such as papers, wires, etc. are removed by passing through filters and screens of all sizes. The wastewater coming out of the filters is then sent into a sedimentation tank. The solid particles settle down and the colloidal particles are coagulated by the use of chemicals such as alum, ferric chloride and lime. And in the secondary treatment, after primary treatment, the sewage water is sent through a trickling filters which contain certain rocks embedded with a thin layer of biological lime or active microorganisms. The active microorganisms are called activated sludge. They remove organic waste by aerobic oxidation and biological degradation. The sludge obtained is dried and used as a fertilizer. So at the end of the primary and secondary sewage treatment consists of the disease causing germs and oxygen demanding waste are removed under tertiary treatment. And treatment of industrial effluents. Here you can see sewage of water treatment, which classifies into primary, secondary, tertiary, and that industrial effluents. And industrial effluents are also classified into two types, that is paper industries and sugar industries. So coming to treatment of industrial effluents, the wastewater let out from the industrial process like metallurgy, manufacture of paints, dyes, rugs, papers is called industrial effluents. It contains both organic and inorganic compounds. The toxic substances like mercury, cadmium, lead, which are non-biodegradable, that means which cannot be dissolved on the earth surface and causes permanent damage into the body of the living organisms. As they are not biodegradable, automatically it causes the permanent damage to the living organisms. The paper industries, the effluent in paper mills contains it contains cellulose fibers, greases, oils and other organic toxic waste. This waste is called black liquor. The black liquor is treated with lime to remove black color and is neutralized using acids. Then insoluble material is removed by filtration. The remaining chemicals are removed by activated sludge process, by oxidation with chlorine and by ultrafiltration or reverse osmosis. And then sugar effluents. In sugar industries, the effluents contain waste of high biochemical oxygen demand, including sugar and proteins. This is subjected to oxidation, where the microorganisms oxidize them to alcohols, carbon dioxides, and then methane. Finally, the disposal of radioactive waste. The nuclear fission reactions are carried out under controlled conditions in a nuclear reactors using nuclear fuels like uranium, mainly uranium-235, for the production of electricity. The harmful radioactive waste during the process are related to 200 radioactive isotopes having long half-life period. These isotopes emits harmful radiations which causes health problems like skin cancer, blindness, deafness, leukemia, physical disorders, and many diseases. Therefore, these wastages cannot be thrown out. They should be properly disposed. The solid waste are collected into leak-proof thick shielded steel tank and buried deep in the underground or beneath ocean floor. The liquid radioactive waste are discharged into a dry well and covered with the soil. The gaseous radioactive are absorbed on the activated charcoal and then it is buried into deep in the ground. This is about the disposal of radioactive waste. This is a brief explanation of environmental chemistry regarding for BSc students. Hope you like this video. If want any videos regarding the next videos, you can comment in the comment section. We'll see the comments below and we'll go through your comments, and hope you can go through the video. You can ask me any topic or any reactions or any mechanisms, so we can make it that in the next video. And then this is Mahesh signing off. Bye.